This is a tutorial on frameworks of Ethereum smart contracts, so it's a little bit hands-on, and you can follow along if you want. And just can I get a quick show of hands? Like, how many of you use Windows computer? How many of you use MacBook? And any Linux? Well, okay. Yeah, so in Windows, I'm not too familiar, but the colleagues in my company actually put on some tutorial on how to, for example, install Hot Hat. Linux and Mac, you can just follow along and just do the very basic setup, it's fine. Yeah, so the first one is Remix. We already talked about in our first lecture. So that's the Ethereum layout. Yeah, so you can also do the injected Web3 in the Remix IDE. That is, if you, in this case, the MetaMask is not in the mainnet, it's in the testnet, the Goerli testnet, and has some test tokens. So if you inject your MetaMask node provider to the Remix IDE, then all the deployment will happen on your test network. So in this case, you can choose the injected provider, MetaMask, and you can use your test network to do some deployment and testing. Yeah, and in this case, you can see there's actually a pop-up when you interact with the contract. So it's more realistic. And now we're going to talk about Hot Hat, which is a development suite. How many of you have used Hot Hat before? No? Okay.
Is that open source? Or?
It's open source.
Okay.
Yeah. It's for Solidity developers, and it has like very comprehensive features. So Hot Hat is a development environment that helps build on Ethereum. It helps developers manage and automate the repetitive tasks inherent in building smart contracts and dApps. And it allows you to easily introduce more functionality around the workflow. This means compiling and testing core. Hot Hat was the pioneer in having a console output in debugging the output, the console.sol. Yeah. So there are 4 advantages for this framework. It has a built-in network, a local Ethereum network, so you can deploy your contracts on the local network and interact with it. And there's multi-version compilation support. You can compile your contract with different compilers. And it supports try assertions, which is good for testing. And you have, and also, the tool that we used before is like Truffle, and I think not many people use it nowadays but it inherits something from Truffle, and the configuration part is quite easy. So here's the steps to install this software. Yeah, if you want, you can follow along. It requires Node.js. For me personally, I use a virtual machine for the development work. And there's a VM that has all the tools pre-compiled. It's called Xeon. So it's actually for blockchain security auditors. But it basically has all the tools pre-installed. So for example, when I use other people's computer, then I don't need to install all the tools on their computer. Yeah, in Windows, first you install this Node.js. Yeah, so this is my VM, and it has all the tool loaded. For example, I can see hard hat. Okay. It doesn't work. Okay. But yeah, so I can create a tutorial. And when you first initiate a project, you do npm init, which is a package init command in Java in Node.js, and you can input some information, and then the project will be initiated, and then you will install this dependency, npm install safe dev hard hat. Okay, play it from command side. Yeah, you will install hard hat in the workspace directory, and then you can also run an npx command to create the workplace. So I'm just gonna use the npx command to see how a workplace can be created. This is the manual way, so that's not really fast. npx, okay. Yeah, so it will download all the dependencies. It might take a while, but once you finish the folder structure, we will explore a little bit. Yeah, as we can see, hard hat is actually kind of heavy. You need to install some dependencies. Yeah, it's still loading.
But there was a recent case of malicious codes being put into GitHub for major packages.
Yes. Actually, that's actually npm packages. So that's actually related to this thing. Yeah. Yeah. So I suggest you create like a virtual environment like me, like a virtual box. So even if it's got compromised, it's fine. But that's one reason I use Foundry now instead of Hot Hat. But I used Hot Hat before. It was the best tool before. But now Foundry is more, it's faster and it requires less dependency, it's safer, and it's better, just good experience, because you can write testing in Solidity, which is the best because you're developing Solidity contracts, and you should write tests in native language. But this one, you have to write testing in like JavaScript or TypeScript. So it's another layer, so kind of a layer of abstraction, I would say. So yeah, I can create a JavaScript project. And yeah, that's my root. No. So they also provide like some sample projects. I mean, like the point of using this hot hat is just to get a taste of the development workflow of, you develop the contract, you test it, and you deploy it locally, and you interact with it. So that's the point of using this tool right now. Yeah, npm gives some lousy warnings, and it's really not safe. I would say a lot of packages have problems.
All these packages definitely better than using just Remix. Right?
Remix is online IDE. I mean, like for example, it's good for like small projects. Of course, I think last year they just developed some desktop version of Remix, so you can actually have a desktop Remix now. It's not perfect. It's still updating, but the debugging and testing is not as comprehensive as those development suite. Yeah. And also today, well, I forgot. So apart from Hot Hat, We also introduced Foundry and Brownie. Foundry is written in Rust, and it's very fast. It can write tests in Solidity, and that's one of the tools that I personally is my favorite. And Brownie is written in Python, and it integrates well with other Python scripts. And a lot of people use Brownies to develop, for example, MVB bot or some trading bots. And it also creates a very quick way, a scaffold to interact with contracts on chain, because it has a console version. And yeah, so you can see the project is created. And this is the folder structure. So contracts will store the contract's code. The node modules will store the dependencies. The scripts will store the scripts to interact with the contract. For example, this one is deploy.js. It helps you to deploy. And testing is written in JavaScript. And we can configure our hot hat here. And this is traditional JavaScript package thing. Yeah, so this is an example on the Windows. It looks like this. Yeah.
How is this better than Remix?
How is it better than Remix? Well, it's easier to test here, and also like you have your own, like for example, your own node. You can deploy your contracts to.
Oh.
Yeah, and it's more convenient for bigger projects, because in Remix, like it's also very slow and easy to get stuck in Remix if you're running big projects. Yeah, and because it's online, and a lot of times, for example, if you didn't save it, and sometimes like if you want to create a new project, it's a little bit like difficult to navigate. Yeah, and especially, I used Hothat maybe 2 years ago, and it had the console.sol file that provides the debugging feature. For example, I had this variable, and I want to know what this variable's value is. I can console.log this value, and it will output in the middle of transaction, which is really nice, because in Solidity, you only see the transaction reverted, but in terms of trying to look deep into what actually happened is kind of difficult there. Yeah, so this is how you import like private key test keys. And this is you configure the RPC node, testnet. There are free options for like RPC providers. For example, like one RPC, or some like Morales network that gives you free options for RPC networks. And some RPC networks have the archive mode feature that you can actually fork a certain block and then replay the EVM machine state at that block. You can also set your gas price and account. And you put your contract source code inside the contract directory. For compiling, you just type in npx hotcat compile, and it will automatically compile everything for you. For deployment, we actually added this deploy.js. Are you guys familiar with JavaScript? How many of you have coded in JavaScript? Well, okay. It's okay. Yeah, so in the JavaScript, we actually just like refer to this get contract factory, which is a function by Hothat, and then the test instance would be deployed by deploying the constant test. We can also invoke function calls in it. For example, in this example, we invoke the test instance get function. And as you can see, there's console log, and you can get the state, the current state. And this is the hot hat deployment stage. You can see the result of transaction, and you can interact with it after it is deployed. Okay, so now it's my favorite tool, Foundry. And what is Foundry? Foundry is a blazing fast, portable, and modular toolkit for Ethereum application written in Rust. It consists of other small tools, for example, Forge, Cast, Anvil, and Chisel. It's not written here, but it's still a useful tool. Advantage is the tests are written in Solidity, and there's flexible debugging, debug logging options. There's DS test style or the hot hat style. And we can see the comparison. The Forge is significantly faster than hot hat in all of the cache scenario. And there's also a fast remote RPC forking mode. And also, we don't need to learn JavaScript in this. So in order to have it installed, we need to have Rust installed. And in Windows, Linux, Mac OS, there's a very easy way to install Rust. After we have Rust installed, we just run this command, and then the Foundry up binary will be installed. And after we run Foundry up, all the toolkits will be installed. And if you want to upgrade the package, we just run this Foundry up. So it's very easy. Forge is the main module. It's used for building, testing, fuzzing, debugging, and deploying. And when we try to create a project, we just type Forge init and Forge. And when we put in our contracts, we use Forge build. And also, there's different options for testing. As a security researcher, I frequently use this debug for testing and also fork URL, which means that it will fork the certain blocks and also gets out like debug information. And this is the powerful feature of Foundry. Let's see. Yeah, this is the code of the contract, and that is the instruction of each step. And this is the stack layout. So you can see different slots have different values. It's very clear. And this is the memory. And this one is a Swiss Army knife called Cast. Cast is very convenient for like some blockchain-related operations. For example, I want to compute this function signature, or if I want to, for example, before I have to go to a website to decode this weird long hexadecimal string to see like what we are signing. But this one, we can actually decode the message in command line. And also, it's good for interacting with RPC. So for example, we can publish a transaction. We can craft a transaction and publish it. And we can get the receipt of the transaction. We can call function just on command line. We can interact with the RPC. We can do some gas-related operation as well. And in Ethereum and Solidity, we have lots of encodings. There's RLP. There's, for example, the unit. The way is not as precise as Ethereum. So if you want to convert different units, it's very easy to use this tool. And also, we can convert a string to a byte32 array. So we can pass that as a parameter to a function. just the example in the morning, for example, when I submit our correct answer of string, we cannot just submit the string itself. We have to convert the string to a by32 array first, and this tool comes in handy. Yeah, also, I personally use this cast to get the storage value. So for example, there's a proxy contract, and in proxy contract, there's an implementation address. And this address can be updated regularly. So when we try to make sure that this address is the one that we're using, we try to access the storage of contract using this small tool, and then the address will be revealed. And yeah, so there's also other two other modules called Anvil and Chisel. Anvil is a fast local Ethereum development node, similar to Ganache. Ganache is the one that's used by Travel and Hothead. So basically, it spins up a local node that you can deploy your contract to. And this one is very new. I think it just came out 2 months ago, or 1 month ago even. It's a fast utilitarian and verbose solidity read eval print loop. So for example, you just want to test something out. Like I have a uint a that's 100, and when I try to left shift it to by hex 9, then I don't know how to calculate this. But if this is in the contract, then I need to find out the value. But if I have to code that a smart contract and deploy it and test it, it's too much work. So I just use this this chisel and find out the B value very easily. Because this chisel it confines to solidity convention, and everything is actually what will be in the output of blockchain. Yeah. So here is the Foundry contract deployment. The project looks like this. And the lib is actually the dependencies. And when we install other dependencies like Forge STD, then it'll be under the lib directory. The script and tests sometimes have overlap functions. And if we want to, for example, invoke the functions in a source, then we usually use test. The code will be under the source directory. When we initiate a directory, hello Foundry, and we see this 4 directory, right? Lib, script, source, and test. And when we compile contracts, we just use Forge build, and for Forge test, it's the basic testing. And we can also increase its verbosity by putting different numbers of V's. Yeah. For contract deployment, we can pass in the constructor arguments in command line, and this is for when you try to deploy your contracts on your test chain or the main network. There's also a new function called verify that you can actually verify that your contract is on Etherscan. Yeah, just to continue, this is a Brownie contract deployment framework. Brownie is food, but it's also the name of this framework. It's Python based. That means it's very popular for people who have lots of script and they want to integrate as part of their workflow. And it also has this built-in smart contract compilation, linking, deployment, and management. The best part about this tool is it has this interactive console for direct contract communication. And also it's configurable build pipeline to support tight integration, and it can use other Python code. And for this one, we have to install pipx, which creates a virtual environment. If you just want to install Brownie without this virtual environment, then like all its dependencies might get polluted and you might get some version conflict. So it's suggested to use the official doc pipx to install this Brownie package. And yeah, so requirement would be Python 3.6 or higher, and PIP3, which is a Python package manager. And the pipx is actually those commands under the hood. So first we create this virtual environment, and then we activate it, and then we install Brownie inside the virtual environment. So, yeah, and this is what I'm talking about, the console interactions. We can create a user, use like Brownie account, generate this test account, and then like we can, yeah, I can just show you briefly my computer. Brownie. So as we can see, we are generating a test account with the mnemonic, that's like English words, and we can use a password to encrypt, and I'm not gonna use a password. So this is my new account. And we can create, we can start a console to interact with blockchain directly. Brownie comes with default a lot of networks that we can choose from. Brownie networks lists. So here's the list of all the networks that it supports. We can also add our new networks if that's not enough. For Ethereum, we have the mainnet, we have the Ropsten, Rinkeby, and Gordy, and Corvam. And for other chains, we have mainnet, testnet. And we can even integrate with other tools like Janash and other Jeth, local classic node. So if I want to start a console, the tool needs to know that which network I'm interacting to. So in this case, I'm going to interact with this AVAX network. So if I type in this command, a console will pop up. A console will pop up, and I can, for example, develop. For example, I can like buy and sell tokens on that network and interact with the contracts there. And before that, I need to like load my account and have it imported in the environment. For creating projects, first we use Brownie init to create a project folder. And in the folder, it's actually similar to Hothead. We have, yeah, this is a more clear version of it. Yeah, so we have a build directory that shows the compilation outputs and deployment information. That's the bytecode and how to deploy it. And contracts, we choose to store the contract source code. And interface is ABIs. So it basically is the JSON version of different like functions and parameters it takes in. And reports shows the test coverage data and contract analysis report. Scripts store contract deployment and interaction scripts. And tests, it just contains some test scripts. It uses pytest, so you can write tests in Python. This is a very simple project that just has this function, set value and get value. Value is initiated with maybe it's 0, but if you invoke the set value with a parameter, then the value will be set, and get is just a getter function. Let's see, yeah. And this is a test script. As you can see, it's a Python script. And first I deploy it from this default account 0, and then I set the value to 5. And then I assert that the contract storage actually got changed. It's actually, the value is now 5. And now I change it to 10, and I make sure the 10 actually happened. So let's just run this. Cool. Okay. So here's my project directory, my contract. And I put my source code inside the directory contracts. Here is that simple contract. And I want to test if this contract works as I expected. So I write a test under the test directory. It's going to be called test mycontract.py. And here are the tests that I want to conduct. Assume that I haven't compiled my project. I will just use Brownie. And now the contracts are being compiled. And we can see under the build directory, there's actually a contract being deployed or being built here. And now we're trying to perform a test. So as we can see, it actually launches a local network because I didn't specify which network to use. So it uses generically under the hood and test mycontract.py. The test passed because the test passed and is successful, one pass. So that means the contract worked as expected. The warnings might be a little bit confusing. That's why I recommend use Foundry as our de facto tools, and I will introduce how to. I will teach you about how to create POC in the next lecture.
I have a question.
Yeah.
Earlier on when you were running the code, it says that I think it was extracted from Istanbul. So does it mean that that's the source owner, that it's from that country?
Source owner?
Source code owner. I saw the country. I mean the city, Istanbul. Turkey.
Oh, Istanbul is a Ethereum stage. For example, right now it's Ethereum London, Ethereum Shanghai. So like after the network upgrade, they give a different name. So Ethereum Istanbul, I think, was an early version of Ethereum virtual machine.
Right.
And let's go back. Yeah, so here's the end of our lecture. Do you have any questions?
If I'm the developer,
Yeah.
okay, you mean those framework like Hardpack, Brownie, Foundry. So I just need to choose one framework to do my work, or
Yeah.
and if it's probably I need to learn these three framework because these tools are probably complementary to each other, or I just pick one and it's good enough.
Some people choose to use different aspects of tools. Some people just to choose one. But if you want to learn other projects' workflows and look at their code base and use their tests, then you have to adapt to what networks they are using. So, for example, I believe AAVE which is a landing protocol. They use Brownie. Yeah. So if you look at their code base, then all their tests are written in those like Python. So you have to adapt to them. Yeah. But nowadays, like Foundry is getting more and more popular. So I think if you want to get an all-around tool, then Foundry is a good option. Yeah. And for people who want to like integrate different tools, they usually have previous background in using one tool, and it's kind of difficult for them to change, and that's why they choose that pattern. But it's always better to have consistency. Yeah.
Question. This is James here. So from the architecture perspective, I want to understand that if you build the contract, you compile it, right?
Yeah.
Into some binary.
Yeah.
Is the binary code distributed across all the nodes?
Yeah.
So there will be a deployment process of spreading it out into all the nodes.
Yes, because every node keeps a copy of blockchain, and the binary code is actually uploaded to the blockchain and stored under the account address. So every node will have that version of bytecode.
Okay. So how does it, when you do a transaction, it knows how to pick up which smart contract to execute?
Sorry, I didn't get the question.
How do you pick up which contract to execute?
Uh,
The virtual machine.
by the virtual machine, because every contract has an address, right?
Okay.
And that's how virtual machine know what code to execute. Yeah.
Okay.
Does that answer your question?
Sure. Thank you.
Thank you. Any other questions?
Just another question.
Yeah.
I know you're going to talk about a language called Move, right? Is it a replacement of this solidity?
It's not a replacement because Solidity is always going to be used for EVM chains. Move is going to be Move is a new language that's being implemented in Aptos right now, and it's going to be implemented in Sui, which is the next big thing. So Move is a relatively new language that's focused on security. So a lot of things I talked today, for example, reentrancy will not happen in Move. And it's not a replacement because people are still going to use Solidity, but Move is definitely a superior language in terms of blockchain development.
For blockchain development, not
Yeah.
for replacement or rewriting code.
Oh, it's for smart contract, yes, but in terms of in the blockchain development sphere, like Move is better than Solidity.
So then if Move is better, more secure, isn't that naturally people will move to Move, right?
Because Solidity has a really big ecosystem and a lot of contracts already in there.
Sure.
So,
I'm putting
yeah.
the migration process.
but users have assets on those chains, so ecosystems, so they will stick with it.
I see.
Yeah,
Because of the asset, not because it's.
yeah,
But for new project, you can
Yes, yes.
So at some point there will be a critical mass where there might be a migration, right, of
Uh,
the whole asset into on solidity into
I,
asset.
I think it would not be a replacement, but a complementary process. For example, a lot of people say Solana has really high TPS, and Solana will replace Ethereum. But Ethereum has its own advantage. It's very basic, and although the transaction is slow and gas fee is high, but there's like layer 2 built on it, and it has a really big community, and there's, for example, the callback, the dynamic part of Solidity, although it brings a lot of bugs, but it also creates flexibility. And Move sacrifice flexibility for safety. So there will be a complementary process instead of a replacement.
So basically, as a developer, you have options. Basically.
Yeah, developers have options. Yeah.
It's like C, C++, Java, you know, different choices.
Yeah, exactly. Yeah.
So from the business perspective, if you want to new initiative, I mean, what is the decision criteria, right? Number one is how do you go about choosing one, developing one? How much does it cost typically?
Yeah.
What is the other consideration as part of the project initiative?
Yeah, there are many trains to choose from to start a business, and it really depends on like what you value and what type of audience you are trying to target. And for example, just two days ago, I was in another hackathon, and a lot of projects are using Solana to build their projects because the low transaction fees, and they think they can bring some real world usage into the project. For example, someone was trying to use like digital coupons. Like imagine if you build a digital coupon system in Solidity, in Ethereum, it'll cost a lot of gas money, probably more expensive than coupon itself. So it's not practical. But Solana comes with its own downside. Like it's not like sometimes the node is not like stable, and the blockchain explorer is kind of opaque. So and also like you need account sanitization, so there's another security risk, and you need to decide like what to choose based on the project needs and the use cases. Yeah, in Solidity EVM like chains, for example, Polygon or layer two solutions like Optimism, the gas fees is already very low, so it's kind of low gas fee version of Ethereum, and you can still build a lot of awesome applications on top of that.